This is PUE in 2 minutes or less. When we talk about PUE, we mean power utilization effectiveness, and this is used in our TCO models for computing facilities costs and for sustainability comparisons. So let's look at an example. We have a host sitting in a data center and it uses 100 watts of power. And let's say this group of hosts also gives off 100 watts of heat. To dissipate that heat, we need air conditioning, and it's going to require 100 watts of cooling energy to dissipate the heat. We also have some lighting and some other things. So to calculate the PUE, we would have the total facility power divided by the IT hardware power. In this case, we have the wattage for the host, the cooling, and the lights divided by the wattage for the host. We have 100 plus 100 plus 100 divided by 100, which gives us a PUE factor of 3.0. So, if we know that the server takes 100 watts, and we know that our PUE factor is a 3, then we know that the total facility power for our TCO will be 300 watts. Now, let's take a look at moving our data center to Siberia. So, in Siberia, we're not going to need any cooling, so let's get rid of that. And to make the example a little more clear, let's get rid of the whole data center entirely and just put our server out in a snowbank. Our server is still going to require 100 watts of power to operate, and it will still generate 100 watts of heat. However, because we're using the planet to cool the server, we don't require any additional watts of cooling energy, nor do we require any energy for the lighting. So looking at our example, we now only have 100 plus 0 divided by our 100, which gives us a PUE factor of 1.0, which, by the way, is the lowest a PUE factor can be. So if we know that our server takes 100 watts, and we know our PUE factor is a 1, then we can calculate our total facility power for our TCO at 100 watts. And that is how we do PUE.